There was a peaceful tower here. Just a Y-shaped excavation, 30 meters huge anchor bolts. This was a scene less than a year before the opening of the World's Fair. Fabrication and erection of the amazing tower was a responsibility of the Steel Division of Pacific Car and Foundry Company. Huge steel anchor bolts, over 30 feet long and 4 inches in diameter, were assembled in 12 rod units. And there were 6 of these anchorage assemblies in the structure. The bottom plates are 1.5 feet square and 3 inches thick. Moved from the shop out to the site, anchor bolt assemblies are lowered onto the concrete pads. The bolts are set at a slight angle, the same angle as the main leg of the tower, tipping slightly toward the center of the structure. Plans call for a continuous pour of concrete. After the anchor bolts and 250 tons of reinforcing steel are in place, 470 truckloads of concrete are poured in something over 12 hours. That's 2,800 cubic yards, the largest continuous building concrete pour in the West. The foundation is so massive that the center of gravity of the structure will be very round. Meanwhile, Pacific Car and Foundry Company shops fabricating the steel core sections. With an extremely tight construction schedule, precision in the shop is a must. Everything has to fit. A template is used plates, central core, and 3 pairs of legs. They're the core truss, ready for milling and painting. The sections are welded in the field, but to be sure that they are set properly, the ends are milled to exact length in the shop. Architects for the Seattle Space Needle were John K. Menashian of Pasadena, California, who has also designed steel structures for rocket launching pads at Cape Canaveral. General contractor in the project was Howard S. Wright Construction. Even the early stage construction, the deft skill of the iron workers fascinated Seattle's most experienced sidewalk superintendents. In order to avoid uneven expansion during this core section welding, one man works on the outside and another on the inside. Raising steel 600 feet in the air on a slender tower was a real problem. Pacific Car and Foundry Company designed a special Derrick crane for the job. Now they're ready to put the jumping jack Derrick in place. The core of the Space Needle is 68 feet above the ground at this moment. Much of the first section was set below ground. A thrust ring at the top provides stability for the mast. Down below is the bearing support on which the base of the derrick rotates a full 360 degrees. To distinguish the derrick and other tools of construction from the rest of the structure, they're painted a bright fire engine red. A 100-ton crawler crane with a 130-foot boom lifts all the steel until the climbing derrick is operating. When the mast is in place on top, they raise the boom. Here goes the outer section. The capacity of the derrick crane is 35 tons. The boom can be operated from a vertical to a horizontal position, as well as turned through a complete circle. Although the derrick goes into position at the 68-foot level, crews will continue to work with the ground crane till the 120-foot level is reached. Meantime, a specially designed hoist is built for this job and completed in record time before the tower runs away from the reach of the mobile crane on the ground. As they test the rotation of the derrick now, note how the operator uses a throat microphone to communicate with the hoist engineer below, and the boom swings round above him. Regular routine on the job calls for about 3 days of welding after core sections are in place. During this time, the raising crews set stairs inside the core. Now the special hoist gets ready to take over the lifting job. There's nearly 4,000 feet of cable on one drum. Specifications call for operating speeds from 11 feet to 400 feet per minute. But the ground crane is still working, raising core sections around the derrick until it's completely enclosed. When it's boxed in on all 3 sides, they're ready for the jump, and the derrick will lift itself up by its own bootstraps. During the course of Space Needle construction, the derrick is jumped about every 7 days. With a cable speed as low as 11 feet per minute and pulley reduction, it's possible to move steel gently enough to crack an egg without breaking it. Usually, it takes about 25 minutes to raise the derrick to a new position in the core. Watch it rise to the 120-foot level. Now the first of 6 main leg bases moves into place. Pointed sleeves on the anchor bolts protect the threads. You'll remember the anchor bolts, like the main legs, are set at a slight angle toward the center of the needle. Because of this, it's necessary to use a special lifting device to tilt the section at the proper angle to slide over the bolts. As usual, everything works like a charm. Rising with the tower, movable scaffolds slide up the legs and the core, a special safety feature on the job. And there's a landing platform every 30 feet on the ironworker's ladder. With no open space for a construction elevator until the project is much farther along, workmen ride up in the skip or climb the ladder. For the Space Needle's mighty tripod legs, United States Steel provided the largest wide-flange beams ever rolled. They're up to 90 feet long, produced from single ingots weighing 28,000 pounds. 3 of them make up a leg section. As you'll see in a few minutes, workmen have to get inside the leg sections to bolt and weld joints in the field. So a manhole is cut in the leg here in the shop. The I-beams are welded together flange to form the leg sections. A sealing strip is added on the outside as a backup bar for the weld and to keep the leg watertight. They're working 3 shifts in the shop now, and the yard is full of main leg sections ready to go. The tubes are stiffened with diaphragms on the inside at a maximum spacing of 10 feet. Here's how they turn the sections so welders always have a down hand to weld. Like the core sections, legs go to the mill, and the ends are finished precisely before they're sent out to the erection crew in the field. Holes for the bolted joints are also drilled in the shop. The entire series is drilled at this time. To make sure of a fit in the field, joints are individually mated in the shop before each section goes out to the site. Temporary bolts hold the plates on one side, the undrilled section is moved in, fitted tightly, and then drilled. Now the 90-foot leg is on its way to the needle. 47 tons of steel in one piece. This first section is raised and held by the crane on the ground while the derrick sets the tie-back box girder to the core, thus avoiding the need for any guy lines. But after these first legs are in place, the jumping derrick will have to handle the whole lifting job by itself. Besides precision in the shop, there's a constant check on construction in the field. Because steel moves just a little with the heat of the sun, the tower is checked for plumbness early in the morning, as soon as it's light enough to see. Step by step, the work progresses without a hitch. Fabricated steel moves out of the shop to the site on schedule. Everybody on this job knows there's a deadline to meet, and everybody takes a special pride in showing the world that it can be done. Thanks to the efforts of all, there are no real troubles except the weather. Members go into place and fit just right. Even the weather didn't cause too much delay. Crews usually found some way to keep the project moving. Now they're up to the 200-foot level, and another leg section goes into place. As you watch the work in progress, you'll see how the workmen use the manholes that were cut in the shop, working inside both legs and girders. At least 20 men are assigned to the work of bolting joints. And before the Space Needle is finished, they'll use 52,000 one-inch bolts and 22,000 3/4-inch bolts, 74,000 in all. The last operation after bolting is welding the plate back into the access hole. Anybody who wants in after that will have to cut his way in. Now the shop is working on the curved legs that move in at the waist of the needle. Each individual beam has its own compound curve. Pacific Car and Foundry Company solves the difficult problem of forming the curves by placing the beams in a simple marked jig fixture and heating wedge-shaped portions of the steel. This causes the material to upset. You can see the heat waves rising from the beam. When the steel cools, the wide part of the heated section shrinks the most and curves the beam. It takes the skillful touch of experienced steelmen to do the job, but when the curved beams are assembled, they fit together just as neatly as the straight beams did. Now the steel diaphragms are in, and they're working on the finished welding. Soon the curved legs are ready to go out to the job site. It's a tricky job for the erection crew to lift a banana-shaped section like this one. Even a moderate breeze can make the steel spin like a spoon on a fisherman's line. But with the air calm, everything goes smoothly, and the curved leg is swung into position, forming the waist of the needle 373 feet above the ground. Just beyond the waist, the legs flare out and change from 3-beam triangular to 2-beam box construction. Here in the shop, a transition leg is joined at the point where the box section begins. The field crew has the same kind of problem with this section as with the curved legs. Even a slight breeze can cause trouble. So they begin to lift at 5 a.m. in the dead calm of early morning. High winds can stop all crane, but no other job for the lifting crew is quite as ticklish as raising a load like this. Inevitably, Seattle's famous Space Needle has been compared with the Eiffel Tower of Paris. Both were built for expositions. Both have become symbols of a city. Both are a steel construction. But the steel of the Eiffel Tower was joined entirely with rivets, 2.5 million of them. Only bolting and welding is used in the Space Needle. And here you get some idea of the tremendous number of high-tensile bolts used in the construction. When the welders do what is known in the trade as back gouging, it makes a spectacular show. Meanwhile, the fabricators assembled a ring girder for the Space Needle restaurant. After shop assembly, small sections from the ring will be joined with the top leg sections. Midway in fabrication and erection, the needle's color scheme has been set, and most members are now going out to the site with their final finish. This box leg is almost 80 feet long and the most difficult lift of all for the derrick. These sections flare out at the top like 6 fingers holding a saucer, and the crane has to work with the boom almost flat. The tower is now at the 500-foot level. Turnbuckles on 1.25-inch rods are raised and guide the section to the core, holding the leg in place until a box girder is raised and set. With only one crane, they can't handle the job as they did with the long first leg. Here again is a small segment of the restaurant's ring girder attached to the top of one of the main support legs. And now, it's about time for a cigarette. While a high wind can stop everything, work proceeds as usual on a rainy morning, as you can see. Box girders move in for a permanent connection between the final leg and the core. And when two of the legs are in position, a ring section is placed between them. Outriggers for the revolving restaurant floor are assembled with a ring section on the ground. It takes 6 sections like this to complete the ring. Each one weighs 26 tons. And since it's what the engineers call an eccentric lift, it's another case of using very slow hoist speeds. The cutout on the fins is 14 feet wide, and a revolving donut-shaped deck will finally sit in this cutout. Now the first ring section is in place, and a steelman salutes you from the same position as a restaurant customer walking over to his table a few months hence. While field crews work only one shift in the Space Needle erection, the unusual demands of the job often call for overtime. For example, with a slow and difficult lift like this, they may get hung up. At times, it's almost dark before they can make a section secure and call it a day. As the sections move up and into position, one by one, the never-ending job of bolting and welding continues. A total of 146,000 pounds of welding rod was used on this job, nearly 40,000 pounds in the field work alone. When the work inside a girder is completed, the top plate goes on for final welding. And here you see the close quarters for a welder inside a box leg. Down below, Chief Seattle seems to approve the project. One ring section is left out, an open piece in the pie, until the last core sections are raised. Rail brackets for the permanent Space Needle elevators protrude from these final sections. Throughout the entire construction period, safety meetings are each week. And although the workers' performance keeps all Seattle goggle-eyed for months, the safety record on the job is unbeatable. Now the tower is almost ready for top house construction above the 500-foot level. The final girder section is raised to close the restaurant ring, but the last 7 cantilevered fins are still missing because there's a lot of lifting that remains for the derrick after it's made the last jump. After the pie is closed, everything else will have to go up by elevator. Corrugated decking, a subfloor at the restaurant level, goes on as a safety precaution during the work that follows. Along with safety on the job, safety of the structure was a primary consideration all the way, beginning with early wind tunnel tests and continuing now with X-ray inspection of welds. The X-ray work is done at night after the regular crew is gone. Now a construction elevator is on the job, giving inspection teams a preview of the Space Needle ride, and they can also see what millions of tourists will see from the tower at night in the months and years to come. But there isn't much time for that right now. As lighter steel members for top house construction are raised to the job, time can be saved with 3 on 1 line. And time is the essence. The deadline gets closer every day. As the basic structure for the restaurant takes shape, temporary supports for the roof girders are replaced with permanent columns. Now the turntable for the restaurant's revolving floor comes up in 8 sections. Made by Western Gear Works, the turntable has wheels that roll on a track, and so easily that it takes only a 1-horsepower motor to turn the revolving deck, tables, diners, and all. Back in the shop, they're matching the sections of the mezzanine ring for the second story of the top house. The sections, 35 feet long and 9 feet 9 inches high, will form an area to contain part of the kitchen space for the restaurant and also some of the mechanical equipment for this fantastic structure. The final section moves into place. These men are working more than 500 feet above the streets of Seattle. Here's how it looks from a helicopter when the mezzanine ring is completed and the crew is about ready to begin work on the observation platform. Pacific Car and Foundry Company's Structural Steel Division, and no other fabricator and erector for that matter, has ever constructed anything like this before on such a limited time schedule. The engineering skill and the ingenuity of an experienced team are put to some real tests. But they're meeting the once-in-a-lifetime challenge with enthusiasm as well as skill, at the drawing boards, in the shop, and out on the job site. The company may never place steel 600 feet in the air again, but Pacific Car and Foundry Company steel has long played a role in the development of the Pacific Northwest, particularly in the region's vast hydroelectric projects, going back to the construction of Grand Coulee Dam on the Columbia River. In fact, structural steel from Pacific Car and Foundry may be found in all the 11 western states and overseas. With the Seattle World's Fair of 1962 still about 5 months away, the structural steel work on the Space Needle nears completion, towering above the Washington State Coliseum on the ground below. Before the Derrick crane is released from duty, it's called upon to lift all the heavy equipment that goes into the tower's 5-story top house. Now one of the motors for the Space Needle's 3 elevators is lifted to the top. And the last lift of all is the stainless steel beacon, the point of the needle. Following the iron workers' tradition, the flag goes on top. The crew sets the gas-lit beacon on a special platform over to one side, where it remains until all other work is finished. Finally, on December 10th, they're ready to begin lowering the hard-working derrick. This operation alone is a big job. The bracing is removed on one side of the core and the crane slipped out. The boom comes out through the hole first. Inching down the long way to the ground, at times the crane is moved through elevator openings that provide less than an inch of clearance. The work begins on a quiet day, but before the job is finished, a storm blows in and gives the crews another rough moment on the job. With wind velocities up to almost 60 miles an hour, crews tie the derrick off the side. Chased from the tower, they wait for the wind to subside. But finally, on December 18th, the last of the derrick reaches the ground. 5.5 months after the first core sections came to the site, a job completed in record time and without one single lost time accident. For this achievement, the governor presents the company and the iron workers this safety award. The president of the Iron Workers Union comes out from St. Louis to accept on behalf of the union. The steel workers are gone now, and the World's Fair is underway. Between the gleaming white space Gothic arches of the United States Science Pavilion and America's first high-speed transit monorail, the Space Needle stands as the dominant symbol of the fair and a permanent symbol of the city. Thousands of tourists ride up the elevators each day, riding outside the core of the tower and looking through vision ports on the world below. In 45 seconds, they're on the observation deck, with a full sweeping view from the Cascade Mountains on the east to the Olympics on the west. And